First, I want to thank all of you for joining us tonight. And I know that you are all looking forward to Saturn. And here we are. And of course, we're joined by none other than the great Carl Sagan. Freshly pulled out of the dryer. And he's going to tell us and guide us and be with us in spirit. And acknowledge the amazing nature, the truly wonderful perception of nature. The fact that the deeper we probe into nature, the more mysterious, the more incredible, nearly incredible, it is that we have arrived here on this razor's edge of possible universes and mathematical constants that led to the ability of atoms to coalesce into stars and galaxies, and for there to be cooler matter in certain, specifically proximal zones near these stars, in some of those galaxies, maybe all. And, well, we're going to look at one of those cooler minor bodies in the galaxies orbiting a singular star in a distant corner of a distant galaxy in an immense universe. So let's find the almost star of the show tonight, Saturn. I always like looking at this fantastic depiction. I'm a fan of the lettering. Big fan of the lettering. Okay, so Saturn, the planet with ears. And what a better fitting planet to listen to ASMR with and to. That didn't make sense, but let's just pretend it did. So, 173 is where we are off to be. There's Neptune. Here we go. Okay. The planet with ears. And Saturn really, although it's second to Jupiter in size, it really, really is the most beautiful thing observable from Earth on a minor telescope, I think, personally. Before we dive in to the gravitational well of Saturn, I just wanted to shout out a few people who requested it. I believe it was, well, Houston, I believe you requested it a while ago. Sparkus. And finally, Dr. Beatus. Dr. Beatus. So, hope you guys enjoy this. A crescent Saturn, here in the picture, looms large over the desolate, icy, low hills of Rhea, one of the planet's 17 or more moons, and I think it does have more than 17 nowadays. Always have to remember when this book was written, because we are going to be reading 1980. So this National Geographic book is from 1980. So you must remember there's nearly, 40 years of science and observation since. So Rhea, about half the size of our moon, and more than 500,000 kilometers from Saturn, gleams bluish in the cold light of the distant sun. Saturn's magnificent ring system appears as only a thin line from Rhea, because Rhea orbits Saturn at about the same plane as the orbit's rings. Looking at them edge on, if you will, but the sunlight casts a wide ring shadow on Saturn. We can see here. The dark patch that links the terminator and the limb just above the thin ring line. When Galileo studied Saturn with his telescope in 1610, he saw the rings faintly as two knob-like shapes, and it really does look like that. Kind of emitting light because it looks like a star. But yeah, vaguely does look a lot like that. And he called them ears. Saturn's moon Tethys, about 2/3 the size of Rhea, is seen in the crescent phase left of the terminator. The moon Dione. Oh, there we go, right there. And then that's Dione or Dione. This is the right of the ring, although only slightly larger than Tethys. Dione, which is called Dione, appears considerably larger as it is closer to Rhea. Rapid rotation causes Saturn bulge a bit at the equator and flatten at the poles. The second largest planet in our solar system, Saturn is a gas giant, and like its neighbor, larger, Jupiter. But because Saturn's clouds of ammonia snow are not so stormy, it's sometimes called the quiet Jupiter. The quiet Jupiter. The quiet Jupiter. The symbol of Saturn looks kind of like a Christian cross with a question mark, the tip of a question mark, or perhaps a scythe. And in the the time of Italy, harvest time belonged to the god of reaping. Okay, so that's probably a scythe. Whom the Romans called Saturn. A symbol curved like this sickle, or sickle apparently, represents the planet. Now on Saturn it rotates at an axis tilt. I suppose ours is 23 degrees, so 26.7 here is actually not that different than Earth. But the length of the day certainly is. Appears to be rotating quite fast, at about 10 hours and 40 minutes. The length of its year is 30 Earth years. So its day is halved, and its year is 30 times. It's going almost 10 kilometers per second in its orbit around the sun. Its average distance, about 1.429, or 1 billion. Wow, 1 billion. Billions and billions and billions. There it is, guys. Our first billion we ran into kilometers from the sun. God, that seems so ridiculously far. What do you think, Carl? That's pretty far, right?
Yes, I would agree.
I think that's how he sounded. Probably not, though. So imagine going all the way from Mercury to Mars, through the asteroid belt, and on to Jupiter. You would have to travel almost as far again to reach Saturn. Here you see the sixth planet from high over its north pole, a view impossible from Earth, since we are indeed pretty much in its plane. Scientists know that at least 17 moons orbit Saturn. Titan, the biggest, holds a thick atmosphere. Phoebe, the most distant, seems here to be partway around the sun. Wow, is that supposed to be Phoebe? Jesus. But only because the sun is shown closer and larger than it really is. Okay, so I suppose these objects here are proportional in size and distance, whereas the sun, of course, is. If it were this distance away, it would probably be, probably too small to even indicate with a single pixel of color. So icy particles moving to this page form the wide, thin rings that wheel above Saturn's clouds. Frigid at the top, the atmosphere grows thicker and hotter without ever reaching solid ground. Saturn radiates excessive energy, maybe because heavier helium separates from hydrogen in the interior. Drops and sinks. The friction releases heat. Saturn's mass is equal to about 95 Earths, but it takes about 760 times its volume. That makes it at least the least dense gas. 100% as dense as water. Because of Saturn's fast spin and flat shape, gravity varies from the poles to the equator. So we see, of course, because Saturn does take 30 years to orbit the Sun, as we go once a year, Saturn's just making a slow progression. So for every one of our spins, it completes 1/30th of a circle. Here we can see the relative perspectives from Earth. From 1971 to, I suppose, the predicted 1995 at the time of this book. Here we have the layers, the cloud tops, ammonia, ice, clear atmosphere, ammonia hydrosulfide icy clouds, water ice clouds, and water ammonia clouds, and more clear atmosphere. And then they think that's just the surface. And they think that liquid hydrogen is the red you see here. Then the orange is liquid metallic hydrogen, so more densely compressed. And then the blue represents water and ammonia. And then perhaps the very center is not solid, but molten, hot, extremely pressurized rock. And the ring thickness for all these measurements of these numbers of billions of kilometers, this one is less than 1/10 of a kilometer, and that would be the ring's thickness. Although they reach out to about 73,000 kilometers on each side from Saturn, whose diameter alone is 120,000 kilometers. Here we have a beautiful artist's depiction of the chaotic yet uniform debris field that forms the rings. It must be pretty exciting to navigate. So Saturn's parallel jet streams and brilliant halo of rings shimmer against the black sky in this enhanced Voyager portrait. Saturn's rings are gigantic. If you could take a spacecraft, a spacewalk around the outer edge, going 25 kilometers a day, it would take you 95 years to get back. 95 years. That's quite the Sunday stroll. So over here, a broken moon, or a moon that never was. Astronomers do not yet know how Saturn's rings actually came to be. We do know that they're full of icy particles, but it seems to blur into a band of unearthly hail around the planet. One ring is so thick with rubble that almost no light can pass through it. So our journey across space from Jupiter to Saturn has taken 1.5 years traveling space station is orbiting at 17,000 miles per hour. Miles per hour, maybe, I think. So Saturn now looms ahead. A huge, misty, yellow globe. Just imagine I think Arthur C. Clarke did a brilliant job of portraying the magnitude and the awe and the looming, just the sheer size of Saturn and Jupiter, of course, but Saturn just looks like a something meant for us to explore. We've been obsessed with shapes, all geometrical shapes, rings, spheres, cubes and triangles and pyramids, and more multi-sided shapes as well. But no doubt Saturn, with its seemingly symmetric configuration and its stark contrast with the velvet black night sky behind it, as we approach, it looms large, and it just must seem so magical to approach. I can only imagine the first astronauts that go out and explore Saturn. It must be a near religious experience, and it's so beautiful to think about. And Arthur C. Clarke in 2001 and the sequels to that did such a brilliant job of explaining what an experience like that might be like. And actually, of course I don't know right now, but I'll probably be putting some Aphex Twin background music, or maybe some original stuff that I recently wrote to try to sound similar to that. And I did that, and I do that in some of my videos because I listened to Arthur C. Clarke's Rendezvous with Rama series, where a mysterious extrasolar object comes flying through our solar system, and we are technologically advanced enough to go intercept it with a spacecraft and a small away team. Yet this team gets trapped, and they get whisked away into another unknown part of the galaxy. And before we know it, what had happened was this vehicle acted as a specimen collector that simply collects species from different solar systems within the Milky Way galaxy and studies them in a very benevolent, benign, very objective manner. And this object, this big, massive, rotating cylinder, can go beyond the speed of light. Has technology that seems organic, yet is so sophisticated. It can hold people in stasis during the incredible acceleration and deceleration that such a ramp up to speeds of that caliber and magnitude would cause. And I listened to this audiobook, and in fact all 4 books. In 2001 I went on a binge a few years ago, science fiction binge, and I had Aphex playing in the background the whole time, and it was so beautiful. It just added so much depth to the experience. And I think that when objects coalesce, these random atoms of our universe coalesce into intrinsically beautiful objects, and majestic and grand and magnificently large objects, such as planets, and especially our Earth. Again, when you view it from that perspective, our Earth is such an oasis in the desert of the cosmos. I think Carl Sagan would appreciate that. I think he actually probably said something along those lines. His writings alone are very elegant and express a lot of wonder for the universe. But, I don't know, that's all to say that I think there is a connection intrinsic to our nature and our minds that we love and find meaning in looking out and projecting and speculating on what might be out there. What positive and perhaps very courageous, very dangerous phenomena might be out there that would take courage and intrepid explorers, but nonetheless would make us better for it. And I think Saturn is in our backyard, and is certainly one of those. So, sorry to digress on an artistic perspective for a minute, but I just find so much meaning in it, and I appreciate that you guys do too. So thank you for watching this. You guys are all so supportive, and it's awesome. But of the planets, Saturn is, of course, second only to Jupiter. The giant has about 95 times more mass than Earth. We already said that, though. I don't know why. I don't know why this book is repeating itself. Okay. Let's finally move on to the next page. Okay, so Saturn gets only 100th. So yeah, that's cool. Saturn only gets 100th of the heat and light that we do on Earth. And about 1 million kilometers from Saturn, we meet the planet's powerful magnetic field. Much stronger than Earth's. This magnetic bubble, pulses in and out with the changing force of the incoming solar winds. But as with Earth and Jupiter and Saturn, has radiation belts charged with solar particles trapped by the planet's magnetic field. If we entered these belts unprotected, the radiation would sizzle us. And these appear to be a picture of its rings. See if there's a picture of its radiation belt. Its magnetic fields. No, it doesn't appear to have any of those. Okay, but nonetheless. Okay, so if I did this right, I will have a picture of the magnetic fields right now, and you can see they expand out. But it's not a perfect sphere, it's actually far from it. And like the book just said, it's very dynamic. what's interesting is that our Earth too is protected from most of the time from the more milder bursts of solar winds. And the radioactive particles in the solar winds do get trapped and do get funneled along the field lines of the magnetic field. As we circle Saturn, get up close to it, streaks of lightning tear through its yellowish white cloud deck near the equator, where winds whoosh. Floating crystals of ammonia ice give the upper clouds a yellowish color, but most of the atmosphere is hydrogen and helium, with some methane and other gases. And the top of Saturn's atmosphere is much colder than the top of Jupiter's. We expected this, considering Saturn's much greater distance from the Sun. But farther down the temperatures rise more than we would expect from solar heating alone. Solar heating alone. Because its core emits heat. So it seems that much as the Voyager unexpectedly, as it probed its upper clouds, it found a shortage of helium, less than expected, in the upper atmosphere's upper clouds. It seems that much of the atmosphere's helium is sinking, warming the lower atmosphere by friction as it falls. Thus, Saturn radiates nearly twice as much heat as it receives from the Sun. And a little history lesson is that Galileo was probably the first to see Saturn through a telescope. And he acknowledged that he reported some odd bulges. He, of course, anthropologically centered them as, I don't know why I said that, anthropocentric, it was in my mind. He identified them as ears. But then, 46 years later, only 46 years later, the Dutch astronomer Christian Huygens identified the ears as the big rings. And then in 1675, the Italian astronomer Giovanni Cassini spotted a gap in the ring, now called the Cassini division. The Cassini division. The outer half is called the A ring, and the inner, brighter half called the B ring. The B ring. The B ring. In 1850, I'm not going to make any jokes about the A-ring. That's for when we get to Uranus. In 1850, other astronomers discovered the faint C-ring. But Saturn's rings story seems endless, really. In 1966 and 69, observatory photographs showed an E-ring and a close-in D-ring. The September 1979 Pioneer 11 spotted an F and G rings, and the rings were named 3,000 kilometers above the atmosphere. Here we go. And band some 420,000 kilometers wide. For those of you imbibing your herbal medications and teas, we prepare to explore the sprawling system that makes the planet one of the most splendid sights in our solar system. We start at the D-ring, the innermost, and find a wispy belt of thin ringlets. Saturn's rings are made up of thousands of such ringlets. And kind of like the grooves of a phonograph. The ringlets are composed mostly of water and ice, but perhaps some of rock, probably ranging in size from dust specks to houses to entire houses. So we have rings with moonlets, the Cassini division between the A, then we can see a better idea of the black Cassini division. It was once thought to be empty, but in fact, it's kind of like how a gravitational body you would expect to act as its. Oh, by the way, you guys should, I'm curious, I mean, he doesn't need the support, he has 500,000 subscribers, but this guy, Peter, draws. It's so cool. I love his channel, but he does all sticky note drawings like this. He's ASMR without even trying to be. But yes, if we took a and that's perhaps Jupiter right there. This would be some rings here, some rings here. And this is kind of what you would expect. It cleans up all the things in its path. So the moons act as attractors, and anything in its relative orbital radius gets pulled in, you know. So it's pretty cool. Just how the universe really organizes itself based on fundamental principles as gravity. But these forces don't explain how we should act in the world, so I'm still leaving room for the concept of morality. That's a whole complex ball of wax. But yeah, a lot of the gaps in the rings apparently form from a gravitational type of tug. Here we go. Orbital dancing. Two of the small moons do a strange orbital dance, unique in the solar system. Oh, I've seen that before. It looks very cool. It's like they form a helical structure. What is that? gravitationally attract to one another. Gravitationally attract. And now they're bound together in the same orbital dance. Same dance at the same distance from the surface of Saturn. And I think that's, again, geez, just so wonderful to think about. But, yeah, I've seen some depictions of it, and it's quite amazing to look at. And then Enceladus, one of the strangest little moons in our solar system. Its surface has many kinds of terrain, old craters around it over time. Newer ones, sharp contours. Rock plains, possibly even volcanoes, because Saturn is so large and there's so many more bodies interacting around it that there's a lot of tidal forces, which tidal forces are just really the gravity being so powerful that it pulls on the body, stretching it, and as you know, rock tends to fracture and crack when you exert too much tension on it. So we have let's call it a midget moon. Dione has something else. He has something else. A midget moon sharing its orbit. Why doesn't the big moon's gravity throw off the small moon? In the late 1700s, French mathematician Joseph Louis Lagrange determined that a large moon's orbit could also hold one or more small moons, but only if they were about 60% ahead or beyond the large moon. And of course, that's a weird effect. Where if we have Saturn in the middle, all its gravity is dominating the Saturn moon system, of course, but we have other moons, and in the interaction, it's mostly Saturn pulling, but it's a little bit of the other moons pulling as well. And as they are not just stationary pulling towards one another, because then they would just simply fall in to each other, they're actually moving around it. And in some weird way, at 60-degree interval, there are weird Lagrange points ahead of it and behind it that act as gravity wells in which a bunch of particles get stuck. So neat. Again, these magical things happen from these fundamental forces. In 1980, Voyager found Dione's little sidekick. These metaphors are too funny. And two others were later found sharing the orbit of Tethys, the Lagrangian moons, each 60 degrees from the big one. And Maria was the second largest moon Titan's king of Saturn's moons. Titan is a special moon. It's larger than Mercury. It has an atmosphere denser than any other moon in the solar system. Spacecraft photos show Titan glowing reddish orange, which suggests an atmosphere of mostly hydrocarbons. But Voyager surprised everyone by finding that Titan's air is almost all nitrogen, like Earth's. Yeah, I thought about it, because I had heard that as well. Some 200 kilometers deep, Titan's air includes argon, methane, and other gases present on Earth's atmosphere. Early atmosphere, sorry. And some scientists think that Titan's atmosphere is evolving much as Earth's primitive air did 4 billion years ago. On Titan, we may have a snapshot of the atmospheric evolution that took place on Earth eons ago. Visitors to Titan will find cold weather, perhaps negative 180 Celsius. God, that's so beautiful. That distance image of Saturn. That's such a beautiful image. Sunlight seeps through layers of foggy methane, casting dim, reddened light on a land made mostly of ice, which is a weird juxtaposition. Usually when you think of heat, but that's very super surreal, I guess. And liquid ethane might perhaps pool on the surface, and many astronomers doubt we could see Saturn through the dense atmosphere. So this is and lastly, our journey continues past the modern Maya pyramid, a pear-shaped chunk apparently covered with dusty ice. We reach Iapetus, another mystery object of almost pure water ice on the side of this moon. On one side of this moon is white as snow and shines 10 times brighter than the other side. The dark side may be covered with dust that falls on the moon from space, or perhaps with a thick, dark, inky substance that oozes from the interior of Iapetus. Farthest of all moons is lonely Phoebe, lovely Phoebe, 13 million kilometers away from Saturn. 13 million kilometers away. It's probably something like 10 times further away than the moon is from us. And Phoebe may simply be a captured asteroid, for it alone revolves backwards around the planet. As our spacecraft hurls past, we recall one astronomer's poem. Phoebe, Phoebe, whirling high in our neatly plotted sky. Phoebe, listen to my lay. Won't you whirl the other way? Won't you whirl? Alright, guys. We have reached Uranus. Uranus, guys. It's Uranus. And I'd like to thank Carl Sagan for joining us on this lovely adventure. This beautiful escape from the terrestrial worries, pressures that we feel of exploring space. But he was also an advocate of using that broad perspective that it gives you about our place in the universe and turning it back on ourselves and recognizing that we are alone in a drift, as far as we know, in this vast, this cosmos, billions and billions and billions of light years across. And it's in our best interest. And it's in the most meaningful way we can perceive life to try our best to be our best, build our skills, become experts in our domains, so that we can help understand each other, and we can help project ourselves into a brighter, more optimistic, more fruitful, more meaningful